we learned that the word mole is simply a name for a number. We already knew that 1 dozen meant the number 12, and now we know that 1 mole means the number 6.022 times 10 to the 23rd. In video number 2, we learned how to determine the weight of 1 mole of atoms of the same element. All you have to do is write down the AMU number of the element and then change the AMU to grams. So 1 mole of carbon atoms weighs 12.011 grams. But most substances on Earth are not just one element. They are made up of atoms of different elements. Substances made up of 2 or more different elements are called compounds. A good example of a compound is water. Most students know that water is made up of 2 different elements, hydrogen and oxygen. There are 2 atoms of hydrogen and 1 atom of oxygen in every molecule of water. And you probably already know the formula unit for water, which is H2O. 2 hydrogen atoms and 1 oxygen atom. Now let's imagine that you're in chemistry class and your professor gives you a homework assignment. By tomorrow, you must determine the weight of 1 mole of water molecules. Well, how do you plan to do that? The first thing you need to do is to make sure that you know your units. Whenever you see the word mole, it should refer to something. And that something is usually going to be atoms or molecules, but make sure to identify which one it is. Many students have lost points on a test because they did not take the time to check to see if the mole was referring to atoms or to molecules. Looking at this assignment, we see that the units are water molecules. 1 mole of water molecules. The next thing that we need to remember is that the weight of a molecule is the sum of the weight of its atoms. So the weight of a water molecule will be the sum of the weight of an oxygen atom and 2 hydrogen atoms. So if we are going to determine the weight of 1 mole of water molecules, we will need to know the weight of all of the atoms in 1 mole of water molecules. Let's think about that for a moment. Every water molecule has 1 oxygen atom and 2 hydrogen atoms. If it does not have all 3 atoms, it cannot be a water molecule. So we need to think of this molecule as a building block or unit of water that always has the same number and type of atoms. In order to keep this clear in our minds, we are going to put the water molecule into an imaginary box. And let's say that we buy 1 mole of these boxes, each box containing 1 water molecule. Now let's ask ourselves some questions. When we purchased 1 mole of boxes, how many oxygen atoms did we buy? Well, let's take our molecule back out of the box and look at it. 1 mole of boxes and 1 oxygen atom in each box. So when we purchase 1 mole of boxes, we also purchased 1 mole of oxygen atoms. Okay, now let's think about the hydrogen atoms. When we purchased 1 mole of boxes, how many hydrogen atoms did we buy? Well, we have 2 hydrogen atoms in each box, and we bought 1 mole of boxes. So we must have purchased 2 moles of hydrogen atoms. Now let's lay all of this out on the screen. We have 1 mole of boxes, which means we have 1 mole of water molecules. And if we have 1 mole of water molecules, we now know that we also have 1 mole of oxygen atoms and 2 moles of hydrogen atoms. Therefore, if we knew the weight of 1 mole of oxygen atoms and added it to the weight of 2 moles of hydrogen atoms, it would equal the weight of 1 mole of water molecules. But how would we ever determine the weight of 1 mole of oxygen atoms? Well, if you've already watched video number 2 of this series, you know that that's really not too hard to do. We simply find the element oxygen on the periodic table and then write down the AMU number. Then we change the AMU to grams and we have the weight of 1 mole of oxygen atoms. Now we do the same thing for hydrogen. Its AMU number is 1.008, so 1 mole of hydrogen atoms will weigh 1.008 grams. Let's round off the 8,000th of a gram just for convenience. Now we have to remember that we have 2 moles of hydrogen atoms, so the weight will be 2 grams. When we add the weight of all of the oxygen atoms to the weight of all of the hydrogen atoms, we then have the weight of 1 mole of water molecules. The weight of 1 mole of water molecules is 18 grams. If necessary, pause the video and study this screen. Make sure that you thoroughly understand it. This is a very important concept in chemistry, and you will use it often in your chemistry courses, both in high school and in college. What you have just calculated is called the molar weight of water, because it is the weight of 1 mole of water, or to be more accurate, it is the weight of 1 mole of water molecules. Your textbook will probably refer to the molar weight of water as the molar mass of water. If that confuses you, make sure to watch the videos explaining the difference between weight and mass. You can find those videos by clicking on Scientific Measurement.